Okay, I figured for today's video, why not just try to record some of what I generally have thought about recording anyway. So this is actually a site I built called Functional Mastery. It's currently very small. This is a workshop. I've labeled it Cybertron 2.0. When I went through my coding bootcamp, the founder had created a workshop called Cybertron for learning functional programming. So I've taken this idea and I've put it online on a website. This is a little bit of background on the website. This one uses the original used Ramda, a library for testing called Tape, and then Rollup for bundling. And this version still uses Ramda, but uses Vitest, I don't know, and Vite for bundling, and then it has StackBlitz for coding in the browser. So if we do lesson 1, so this is just some practice to get, some examples to get practice with map, filter, and reduce. So the idea here is, you take functional programming is, things kind of go in reverse order. So if we have a doubled function, it would just be double x times 2, and so I'm probably going to get this wrong at times, but here we would just say map, and then we would pass it the double function, and then the numbers array. Okay, so we got 1 passed down here. I don't feel super stupid. That's good. And so these, in functional programming, they read right to left. So instead of passing in numbers first, you pass it in as the second argument. I think I could also do like that. Yeah, and that still works too. And then so here we want to filter to only return even numbers. So filter takes item and returns x 2 0, and then here we just say let's say filterer, and we'll say filter numbers. All right, we get 2 passing, and then reduce is for some reason always a pain for me. So here we can do, what are we trying to do? We want to reduce to the sum of the numbers. So that's the classic accumulator plus the element equals a sum. So it's reducer equals accumulator plus element. And then if we do reduce, I think it's initial value, reducer, and then numbers. I might have a order off on this, so yeah. Oh, so I got it. Kind of makes you happy when you finally get stuff. Okay, now we want to use compose to run the following 3 commands. So compose is you bring all the functions in from right to left. You could actually probably bring in pipe, and I'll show the difference between these two. But so we have 3 functions. We want to square each number. Square x equals x times x. And then our filter equals x divisible by 8, 0, and then reduce to count the resulting numbers. I do know that this one always trips me up for some reason, even though I've went through this and I made a whole site on it. Well, let's just use our old friend Google to say how to use reduce in JS to count numbers, number of items in an array. We usually get a decent answer here. Okay, so then if we come back here, let's reducer, accumulator element, accumulator plus 1, and so we're actually gonna call this our reduce function, and then we'll have a reducer which will be reduce with the, what was it, the reduce f function and value. So these are all in functional programming called curried functions, so they're awaiting their arguments with the function name from or with the function from Lambda. So this is curried, it's waiting on its third argument right now. So then we can use compose, and things read right to left, so we want to map, and then we filter, reduce, and we want to do that over our numbers array. Okay, so, well, that would make sense because I don't have, we want to map here we can do this squared. What was this map? It's going to wait on its second argument, right? Because that takes, yeah. And then filter is going to wait on its second argument. So then we'll do this of square and filter and reducer. I don't think there's really any. Oh yeah, there's. I did that really wrong. Okay, let me undo this, and then we'll just change this to filter, 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 and square, map, square. Okay, so I've added it in the real wrong place because I needed the whole function to be wrapped. So yeah, so this is compose. So compose reads right to left. So we're taking the numbers and we're sending them through the map function, and whatever that return value is, we're sending through the filter function, and whatever that return value is, we're sending through the reducer. Pipe is the exact opposite. So if I comment that out and run return pipe, we'll send it the map square, the filter, and reducer, and then they always still read the arguments passed in at the bottom like that. So that's how pipe would work. and that is exercise or lesson 1 of this Cybertron workshop. I guess technically I have, well, these are difficult. Some of these are. So, but that's lesson 1, and we can probably go through a few more of these in later videos, maybe just pieces of them because some of them are longer. So, yeah, this is day 5. Thanks.